Hey there, Seahawks. It's Miss Adams, and in this video, we're going to learn how to determine sample size for a confidence interval. So really, we'll be finding the minimum sample size that you would need in order to meet the conditions of your interval. And this is a lot more algebra based than almost everything we do all year. So most common critical values, remember you want to know those. 90% is 1.645, 95 is 1.96, 99 is 2.576. Your confidence interval, again, is your statistic plus or minus your margin of error. To maximize the margin of error, we use the most conservative p-hat value that we can, which would be 0.5. 0.5 for probability of success, 0.5 for probability of failure. That gives us the largest margin of error possible. All right, so this one, sample size with proportions. Daisy wants to make a one sample Z interval to estimate what proportion of her community members favor a tax increase for better pay for local law enforcement. She wants her margin of error to be no more than plus or minus 2% at a 95% confidence interval. What is the smallest sample size Daisy needs? So in order to make sure she has a margin of error of plus or minus 2%, we need to figure out what sample size should she be doing. So margin of error is going to be plus or minus 2%. 0.95 is going to be the confidence level. They did not give us a proportion, a sample proportion. So if I don't know that, I'm going to use 0.5. So margin of error is equal to Z star times the square root of p hat times 1 minus p hat over n. I'm going to fill in the pieces that I know. Margin of error is 2%, so 0.02. Z star for 95% is 1.96. The square root p hat, I'm going to use 0.5 because they didn't give me a sample proportion. 1 minus p hat would also be 0.5 over n. I do not know n, that's what I'm trying to solve for. So now I'm going to do algebra. So I'm going to divide both sides by 1.96. That gives me 0.0102, and this is still the square root of 0.5 times 0.5 is 0.25 over n. I want to get rid of the square root, so I'll square both sides. When I square that, I get a very small number. 1.04 times 10 to the negative 4 would really be 0.000104. So if you want to write it like that, you can. Then what I would do is multiply both sides by n, and then divide 0.25 by that 1.04 times 10 to the negative 4. But there's multiple ways, different algebraic approaches you could take to get n by itself, and we get 2,401.00001. If there's anything more, even like a fraction, a little tiny fraction, you're always going to round up, okay? So the minimum sample size that we would need would be 2,402. All right, the next one, sample sizes with means. Jason wants to create a confidence interval to estimate the mean time spent doing non-work related tasks while at work for his employees. He wants the margin of error to be no more than 10 minutes at a 90% confidence interval. A preliminary study suggests that non-work related time have a standard deviation of 15 minutes. What is the smallest sample size Jason needs to obtain the desired margin of error? All right, so typically when we're finding the margin of error for means, we would do x bar plus or minus t star times sx over the square root of n. T star relies on degrees of freedom, which is calculated by doing n minus 1. And we can't find that without knowing n. So instead, we're going to use z star in its place. All right, so margin of error would be 10, 90% is my level, and they did give us the standard deviation of 15. They give us the population standard deviation, which is why we're allowed to use z star instead of t star. So margin of error is plus or minus 10, confidence level is 90%, sigma is 15. All right, so I'm going to plug 10 in for margin of error. Z star is going to be 1.645, standard deviation of 15 over the square root of n. Now I'm doing some algebra to solve for n, so I'm going to divide by 1.645 on both sides. That gives me 6.079. I'm going to multiply both sides by the square root of n. That's just kind of moving it so it's not in a fraction anymore. I just kind of rearranged it. So I have 6.079 square root of n equals 15. I'm going to get rid of that 6.079 by dividing. 15 divided by 6.079 is 2.4675. That's equal to the square root of n. Well, if I want n, I'm going to square both sides. And I get n is approximately 6.0886, and anything at all beyond that, I have to round up. So n is 7. All right, go Seahawks.